first. So solve the equation. We use the quadratic formula in the MF19 as usual. So the x in the formula is z in this case, and for the a, b, c coefficients, this is 1 for a minus 2 pi, so the I is included for b, and for the c minus q. Now we plug into the formula and we simplify. So minus minus, we get positive 2 pi, and when we square this we have positive 4 p squared I squared, and when we multiply we have plus 4q. Now I squared is negative 1, so that's why we have minus 4p squared here. And then we can factor out the 4, so we have 4 times minus p squared plus q, or q minus p squared. The square root of 4 is just 2, so we divide by 2. 2 divided by 2, we get just 1, and this is also 2 divided by 2, we get just square root q minus p squared. So this is the solution. Now for part B. Given that a and b lie on the imaginary axis, find a relation between p and q. Okay, so first of all, distinct points. The roots of this equation are represented by distinct points, so this means we have two roots. Now if we have two roots, of course this plus minus cannot be just 0, or this thing cannot be 0, because if there's no plus minus, we have only one repeated root, or there is no distinct points. Okay, so it cannot be 0 here. And since a and b lie on the imaginary axis, that means the real part, so this is the imaginary part, the one with I, this is the real part. The real part cannot be something other than 0, basically. Okay, so this part here must be imaginary, basically. Okay, so it cannot be 0 because we will have only one point, and it cannot be real because it's on the imaginary axis, so it must be something imaginary. So imaginary means inside the square root must be negative, so that's why we have this, and the simplest form is q is less than p squared. So this is the final answer. Okay, so two roots and imaginary, so that's the key. The last part, given instead that triangle AOB is equilateral, so from the previous part we know this is the z, and the a and the b are the roots, so this is the a, this is the b, and we need to show that AOB is equilateral. So obviously for the length, this is the same as this. We only need to know, or to show, that this angle is 60 degrees and it's therefore equilateral. So if we just split this triangle in half, focus on this part of the triangle, we know that this length here is p, because that's pi, and we know that this length here is q root q minus p squared. This is the length. Okay, and given that equilateral, okay, so this is actually equilateral, so this is 60 degrees, which means a half of the angle is 30 degrees, so this is 30 degrees. So now we're using tangent. Tangent 30 degrees is opposite over adjacent, so square root q minus p squared over p. Tangent 30 degrees, use a calculator, that's 1 over root 3, and square both sides, and then we cross multiply. 1 times p squared, 3 times q minus p squared, and then we add 3p squared to both sides, and we divide both sides by 3, we get q in terms of p. Alright, I'll see you again next time.